of the screen or are operated in slightly different manners. We're going to create a pull-down menu, so place a 1 in the first line of the menu file. Starting in the first column of the next line, place the name of a heading within single quotes. Headings for pull-down menus are displayed at the top of the screen. Indented text in lines below the heading will be subheadings or actions. They are also placed in single quotes. In our menu, we'll add 2 subheadings, Clear and Draw Land Use. These will be displayed as text below the screen function's heading. When the Clear option is selected, the Clear command will be invoked. When the Draw Land Use option is selected, the commands Map Extent Land Use and Arcs Land Use will be invoked. A semicolon can be used to separate more than one command on a line. Now let's add another heading, again beginning in the first column. Then we'll add 2 options below this heading. Query and Quit. The Quit command is necessary so that we can stop the menu file when we want and return to using commands. When the Quit option is chosen, the ampersand return directive is invoked, which closes the menu. Now, save the menu file. Now, before we invoke the menu, start the ArcInfo session and start the ArcPlot program. Now remember, before we can use any kind of screen menu or draw graphics, we have to tell ArcInfo what kind of workstation we're using. Now we're ready to invoke the menu. Use the ampersand menu directive with the name of the menu file following it. The 2 headings, Screen Functions and Get Information, appear at the top of the screen as the menu bar. By clicking on the Screen Functions heading, the 2 subheadings Clear and Draw Land Use appear. Now simply move the cursor or mouse to the Draw Land Use option and press the space bar or release the mouse button. The actions next to Draw Land Use in the menu file will then be executed. Map Extent Land Use, then Arcs Land Use. We can continue using the menu in different ways. When we're all done, use the Quit option to return control back to the ArcPlot session. So menus are simply text files that conform to certain rules. The first line contains the type of menu. Lines that begin with text in the first column are headings, and lines that are indented are subheadings and corresponding actions. To invoke a menu, use the ampersand menu directive. Additionally, variables and functions could be used in a menu file just as they are in a macro file. You can create simple macro files to help you standardize or automate procedures like viewing coverages in ArcPlot. You can use them to set your editing environments in ArcEdit or perform an analysis. You could also make menus so that new or inexperienced users can quickly do simple tasks with ArcInfo. The basics of the Arc macro language are the same on all workstation and many computer versions of ArcInfo, so you can share your AML macros with colleagues at other ArcInfo sites. Because AML is a powerful programming language, you can use it to develop entire applications and user interfaces, or you can use the power of the AML language in simple macro files and in your everyday use of ArcInfo. To learn more about the Arc macro language and go beyond what we've seen here in this videotape, there are several sources you can use. In Understanding GIS, the ArcInfo method, Lesson 10, Customizing ArcInfo, is a clear and concise introduction to the Arc macro language. The Arc macro language user's guide has complete references to all the AML functions and directives, as well as chapters on AML concepts and coding standards. The ArcShell menu interface to ArcInfo can be used as an example of a sophisticated menu interface. You can see how the macros and menus are written or use them in your own macros. The Applications Programming course is a 3-day class that introduces the power and applications of AML in a classroom environment. Along with these resources, this tape is intended as a starting point in learning AML so you can begin creating macros and menus to suit your own needs.
California school districts are facing complex decisions to provide housing for student population growth. Many district populations are growing at double-digit rates, while at the same time, unavailable or scarce funding makes facility planning decisions ever more important. Many of the questions being posed by administrators today can be effectively answered with the proper tools and techniques of long-range planning.
Well, master planning is an ongoing series of planning procedures designed to study, forecast, and prepare for student population changes and the effect these changes will have on school districts' facilities. Master planning and its consequent demographic studies can be invaluable in evaluating alternatives, such as what school facilities should be required to meet the needs of the community, and when will they be required? Where should any new facilities be located? What should be the planned capacity of new facilities? And what is the optimum grade level configuration consistent with the school district's educational plan? Are there existing facilities that could be candidates for alternative uses? And if so, where are they located? Where should attendance boundaries be drawn to accommodate future enrollment growth or decline? What about the transportation of students? In general, master planning allows the answering of these questions, and in doing so, prepare for the future.
There are many methods and technologies available to the planner when preparing demographic studies for a school district. One of the fastest growing fields is what is commonly referred to as geographic information systems. Now, what is a GIS? A GIS is a decision support system composed of software, data, and procedures used to integrate, display, query, model, and report on geographic data. Now you may ask, how does this ability relate to school district planning? If you think about the planning questions previously mentioned, they all have a common denominator. That is, they all relate to location. Where should attendance boundaries be drawn? Where should new facilities be located? Which areas have growing or declining enrollment? And where should students be transported? In addition, master planning requires a large volume of data collection and analysis, and a GIS has the ability to categorize and maintain information that can be easily retrieved and studied.
There are several advantages to the GIS approach. A GIS provides the ability to relate planning information to a geographic area in the district and to build geographic relationships between the planning data. For example, the simple location of an address can be determined from a map of the district. A GIS allows for the interactive locational query of a database of information by an area of any size or shape. A true GIS allows the overlay and combination of two or more distinct sets of data by location, thereby creating new information for analysis. For example, a map showing the location of all students could overlay a map of district study areas to combine the information of both files. This would assign all students to a study area. Another example would be to overlay these study areas with a map of land use zoning to obtain the percentage area of each zone type in each study area. A tabular database and many systems purported to be GIS do not have this capability. A school district GIS has the ability to model and forecast enrollment for any predefined area of a district. This information is related directly to specific geographic areas where it can be used to interactively test various facility planning scenarios or boundary simulations. A properly designed GIS database allows the planner to store, retrieve, and edit the large volume of information used in the planning process and to build an ongoing base of historical data for use in future enrollment projections. A GIS allows for a much wider variety of locational planning studies, including the display, plotting, and reporting of information based upon geographic criteria as well as tabular data.
Although many districts are recognizing the advantages and need for a geographic planning system, there are two major barriers for individual districts establishing an in-house system. First is that a GIS usually requires a trained person in GIS and database principles in order to effectively maintain and use this system to its fullest potential. Secondly, and a related issue, is the fact that costs to individual school districts can be prohibitive. Proper hardware, including digitizers for accurate map updates, plotters for large-scale presentation maps, software, and the time for street network and database creation effectively eliminates many districts from using this type of system. However, Neptune Thomas Davis has eliminated these barriers for districts wanting to use this type of planning system.
NTD has developed a geographic information system which it utilizes for all its planning and studies and demographic consulting services. In essence, NTD has become an extension of the district planning staff, providing ongoing updates and information at the client's request. The effort behind this system was accomplished in cooperation with the world leader in geographic information systems, the Environmental System Research Institute. All geographic information systems require certain basic data in order to operate. Commonly, the most difficult, time-consuming, and costly aspect of a GIS is the preparation of an accurate base map of all streets within the district. With NTD's system, updated digital map data is accessed and imported from a variety of sources. NTD primarily uses ETAC computer street maps, which are widely accepted in the GIS community as the most up-to-date existing street file currently available. These maps are supplemented with updates obtained from local planning agencies, fire departments, and field research. In addition, NTD can utilize Census Bureau Tiger and Dime files, digital Thomas Brother map files, and city and county digital files for those government agencies using ESRI software. Agencies such as the San Diego Association of Governments, the counties of San Bernardino, Riverside, and Orange, the Los Angeles County Regional Planning Department, Caltrans, numerous cities, and hundreds of other organizations in California utilize ESRI software, providing a wealth of existing compatible data sources. Once an accurate street map is created, a district is divided into statistical collection areas known as study areas. These planning areas are the smallest unit within the district for creating a base of historical data used in enrollment projections. By combining the projected students from various study areas, existing school enrollment projections can be created. In addition, future facility requirements can be shown and attendance areas defined. Student data files are extracted from the district and imported into the GIS database using a template defined specifically for a particular district. Basic information required for enrollment forecasting includes student grade level and address. Information contained in student records that a district may wish to geographically analyze may also be incorporated into the system. Once the student data is loaded, address matching can proceed. This process links students to a specific location along the streets of the district. It creates a basic electronic pin map of students within the district through which demographic characteristics of the student population can be queried and displayed. In addition, a variety of locational studies may be performed on the data. With address matching, NTD can determine how many students in each grade level live within any distance of any particular school. In many developing districts, A map layer containing the location and information pertaining to new residential construction is created. New tentative subdivision maps are sent by local planning agencies to a district for comment and then forwarded to NTD for cataloging and file update. As a part of NTD's service, these files are periodically reviewed through contacts with developers and city and county officials. The information may be queried for reports, plotted on maps, and when utilizing the integrated GIS forecasting programs, the estimated number and types of dwelling units per year is loaded into the student projection model. Existing school locations along with district-owned sites are maintained in a map layer along with information such as grade level configuration, facility inventory and capacity, and other planning data. NTD's system is flexible and allows for an unlimited number of data or map layers to be integrated into the planning process. Optional layers of information may include but are not limited to the following: city or county planning areas, land use and zoning information, assessor files, address matched, creating valuable information for dwelling unit yield studies, seismic zones as added information to facility siting. In addition, recent aerial photography can be scanned and incorporated into a district's GIS database, giving additional update capabilities and planning insight unavailable with other geographic information systems. All of this information can be displayed, queried, combined, and analyzed, providing reports and maps to a school district. In addition, as distributors for ESRI GIS software and ETAC digital mapping, NTD is also able to offer a PC version of the display and query system for a district's in-house use. But master planning is more than the reporting, display, and mapping of existing data. NTD utilizes the information contained in the GIS database to produce accurate enrollment projections. These projections, along with the strong analytical power of the software, are used to redistrict around existing school facilities and proposed sites to determine the extent of required new facilities, their location, and timing. Neptune Thomas Davis has been able to utilize its planning and GIS expertise in a variety of district projects. Using a flexible and open system, Neptune Thomas Davis GIS allows the firm the ability to provide a wide variety of planning information and studies. Using numerous existing and compatible digital data sources, the firm is able to immediately begin creating useful information for each school district. Information such as enrollment projections, residential development monitoring, optimum facility site locating, boundary analysis, facility evaluations, transportation studies, and updated district mapping. With the most powerful GIS today and support from Neptune Thomas Davis, planning for the future has been made timely and affordable.